Hi everyone, Chad here. Thank you for joining me. Today we're going to write a size exclusion method or SEC method for the Avant. In fact, we're not going to do one method, we're going to do two. I'm just going to take the first one and adapt it. So the first one's going to be pretty simple. We're going to use the sample loop to be able to load the sample, and then we're going to use like very basic fractionation. And then for the other method, we're going to use the sample pump, which will allow you to do multiple runs and many of them all at once. And then we're going to use peak fractionation, which will save you a bunch of like fractions. For this method, I'm going to use the HiPrep Sephacryl S200 column. That's 2660. That's 26 millimeters by 60 centimeters high. You can get this column. It's pre-packed. It's available through Cytiva. But you can use this method with any column really. I have an entire video about like creating a custom column in Unicorn. We're going to use the two variables I want to tell you about is the flow rate is going to be 2 mils a minute, and we're going to collect 2 mil fractions every time. And then there's going to be some other variables that I'm just going to put up on the screen here just so you know like sort of what the plan is. So in this video today, I'm going to assume that you know a little bit about writing methods in Unicorn. If you don't, that's fine. If you're brand new to writing methods, I have some videos you can watch I'm going to put up on the screen here, and you can go see those and then come back and you'll do great. You don't really need to know a lot about writing methods anyways. So let's dig right in. I'm going to turn this off right here. So the first thing we're going to do is click this button, which is create a new method. And like I said, we're going to do a custom method. So we're going to select empty method, and then we're going to want to make sure we select the system that we're trying to write the method for. And usually you only have one system in here. And what comes up is a method settings phase, and this is just all the default variables that are in Unicorn. What I like to do when I'm like writing a method is I like to populate all the method phases like right away. So I'm going to do that right now. And how we're going to do that is we're going to go to View and then Phase Library. And then we're going to get this window. We're just going to hit OK and click through that. And then I'm going to go all the way down here to the bottom and click on User Defined and just drag this up. And then I'm going to rename each phase what I want to call it. And this one's going to be System Flush. All right, so it's that easy. I'm just going to do the rest of them here. Okay, great. So those are going to be all the phases I'm going to use. So I'm just going to X out of this box right here. And then this gradient view on the bottom, I'm going to X that too because we're doing SEC. There's no gradient we're using. So this is just going to get in our way. All right, now we have a bigger space to view what we're doing. All right, so the next thing I'm going to do is I am going to select my column. So I'm going to select this right here, the base, and then I'm going to go down here to the column type, and I'm going to select my HiPrep 2660 S200 resin, and I'm going to hit change. And then what comes up is a window that says, hey, these were all the default settings right here, and this is what we want to change them to. And I'm going to hit OK. Generally, it's a good idea to do that. And then the next thing I'm going to do is I am going to get rid of all of the variables here that I don't want to see. And that just helps streamline this video. But how I'm going to get rid of any variable that I'm looking at is where it says I'm going to click on the instruction, right? And if I see this capital AR in VAR, right, I'm going to click on that, and I'm just going to hit clear and then OK, and then change. All right, so now I'm going to do that for all of these, like for the wavelength and for these extra pressure alarms and whatnot. All right, So I did leave some of the variables, like I left the column position variable, the pH valve variable for the flow restrictors. Maybe I should have kept the column pressure variable. Yeah, let's do that. I'm gonna add this here. Okay, well, I got rid of maybe one too many, right? Gotta put it back in. All right, so now the other thing I'm gonna change is the flow rate, and I'm gonna do this. It says 2 mils a minute. Okay, and something I wanna show you is for this column right here that we picked, I'm gonna click this button, which is column handling. And then I'm gonna go down to the column that we're doing, which is this 2660 S200. And I want to show you that the maximum flow rate, the default flow rate is 1 mil a minute, but the maximum flow rate is 2.6 mils a minute. So we can do 2 mils a minute for this column. In practice, I've noticed that this column works great with 2 mils a minute. It's a pretty big column. 1 mil a minute will just take forever. Okay. So now for system flush, I have the flow rate at 2 mils a minute already, so all I need to do is change this to volume for the base. And I'm gonna hit cancel because this wants to change the flow rate back to 1 mil a minute. Hopefully it only asks us that once. All right, and then what I like to do is just have, you know, a couple minutes, 5 minutes really, 5 mils, where I'm just washing the entire system out just in case there's any air in there. In fact, I also need to do a pump wash in here, so I'm going to put that in this method, the end of this method settings, or maybe I'll do it in the system flush. So I'm going to go here to pumps and pressures and pump wash, and I'm just going to wash A1. Okay, so now I have a pump wash, and then I'm just gonna wash the system for 2 mils a minute for 5 mils. Okay, so now we're gonna go to the column equilibration. The column is in bypass right now, so I actually need to turn on the column. So here in column equilibration, I am going to go to, I'm gonna get rid of this variable for column bypass. For column position. Actually, I'm even just going to get rid of the entire instruction because I want the column position in the column equilibration phase. Position 1. And insert. Okay, and so now the base here is SameAsMain for this phase for column equilibration, and the base is CVs currently, right? So now I'm going to equilibrate the column for 1 CV, and I'm going to make this a variable too. Change. Okay, so now I'm equilibrating the column for 1 CV. Okay, so now I'm going to load samples. So this is where all the magic happens. Okay, so I'm using the injection loop, right? I'm using the injection valve, and I'm just going to use the sample loop. And in this scenario, you can imagine I have 2 5 mil loops that are connected end to end, so I can inject a total of 10 mils all at once. And so I'm going to try to inject 10 mils. So the first thing I'm going to do is I'm going to change the base to volume because that'll just make things more convenient. And here it's asking me to change the flow rate again. I'm going to hit cancel. But the base is changed to volume now. And then where the magic happens is right here. I'm going to do the injection valve, and I'm going to click inject, insert, and then I'm going to do it again as manual load, insert. And so manual load is the default position of the injection valve. So this is where it's in manual load, it's bypassing the injection valve, and in inject, it's the sample loops are open, so they're part of the flow path. So if I click right here and put 10 mils for these zeros, that'll be the volume I inject. All right, the next thing I'm gonna do is the actual separation. Right, so someone asked me if there's a way to collect starting at 0.2 CVs and then collect 35 fractions. I know it says up to, but I'm just gonna say 35 fractions and then stop collecting fractions. And then we'll end the, continue the separation until the run is done. So the first thing we're gonna do is go to fractionation. And we're gonna do 96 dipole plate. We're gonna collect 2 mil fractions, right? And I'm gonna do this as a variable. And then the point at which the break point this is gonna start at is gonna be 0.2 CVs. Okay, and so then we have to figure out if we do 35 fractions would be 70 mils, right? So we need to figure out what percentage or how many column volumes 70 mils is. And it's 0.18867 CVs. So we'll just say it's 0.19 CVs. So I'm going to say stop fractionation at 0.39 CVs because 0.2 plus 0.19 CVs is the amount that I want. So I'm just going to do insert. And then I want to finish the separation after 1.25 CVs. So I'm going to change that right there. Yep, and that's our method. So the first thing we're going to do after saving our method is we're going to say, after finishing our method, is we're going to save the file, the method file itself. Save. All right, then the next thing I'm going to do is I'm going to tell Unicorn where I want the resulting chromatograms to be saved. So I'm going to click this button right here. And I don't want it to go to default home. I want it to go to the training folder. And then I want to be able to review some of my variables. So I'm going to click on the variable list and I want to make sure the result name and location are selected. And then that's it. I'm going to hit save again, and that's the very simple method. So now for the second method, and this method has two key differences. The first one is that we're going to use the sample pump for loading, and we're going to do that part first, and then the second part is we're going to use peak fractionation. For the sample pump loading, the first thing we're going to do is I'm going to take the system flow and I'm going to turn it into a synchronized block so that I can repeat it later. And I have a whole video about synchronizing instructions. So that's going to require a block. And when you do this, you just type something here. And I'm going to take this system flow instruction and I'm going to cut it. And I'm going to put it inside the method flow rate block. Okay, so there's that part of it. So then I'm going to leave system flush just like it is, and column equilibration, that's not going to change either. So I'm just going to hide these. All right, so load sample is going to change. Okay, so the first thing we have to do is turn off the system flow rate. We can't have the system flow rate and the sample flow rate the same at the same time. We're going to change the injection valve to inject. So I'm going to switch these so that the system flow stops first before we do the injection valve. Oops. I had it right and then I turned it back around. Okay, yep. Still system flow on top. Okay, there we go. All right. Okay, then I'm going to define where I want the sample to come from. So that is the sample valve, sample inlet, and I want it to be from S1, insert. Oh, and since I'm doing this right here, during the system flush phase, I am also going to add a pump wash. So this is going to wash the buffer line of the sample pump. And then this one, I'm going to clear this. Okay, insert. So now I'm going to do 2 washes, one for A1 and then one for the sample buffer. And this will clear out any like unusual solutions that are in the sample pump, right? Okay, so we got that going. So we left off at the sample injection valve was defined, and then we're going to turn on the sample flow. Make that a variable. And then I'm going to get rid of this manual load right here. Delete. And then I'm also going to get rid of this breakpoint. I'm just going to do a 0. Okay, for right now, I think I'm going to change that later again. But okay, so the next thing is I'm planning still on loading 10 mil volumes, right? But I'm going to put in a watch instruction, and I have a whole video about watch instructions. So if you're not really sure how that works, just go watch that. And then, so the signal is going to be air in the sample valve. And this is just if that we run out of sample on the, like for the sample pump, right? So if the sample pump encounters air, that's test as equals air. And then the action is just going to be end block. All right, and then this is going to be our variable for the sample volume. So I just changed it back. All right, it's all about the process. We moved where the injection volume variable is though for this method. So that's the load sample phase. But now I need a new phase where we're going to reset the system. And there's a bunch of different ways to do this, but this is just how I like to do it. So I'm going to go back to the phase library. And so for reset system, I'm basically going to do each of these things, but backwards. So I can skip that one. So for sample flow, that's the last instruction here. So it's going to be the first instruction here. So I'm going to turn that on to 0. And then I'm going to turn the air sensor watch instruction off. And then I'm going to change the injection valve to inject. To manual load. And then I'm going to put in the synced block for the flow rate. Okay, so now if I change this here, it'll change down there. So I'm going to do, like, for example, 2.1 change. So it says 2.1 here, and now it says 2.1. That's a synced block. All right, change it back. So now I've done the method flow rate as well. So let's just double check everything. All right, great. So that is injecting with the sample pump. That's all set up. So now let's do peak fractionation, and that's pretty easy to do. So I'm going to close all these things for load sample and reset the system, and we're just going to focus on the separation phase. I'm going to close this too. All right, sorry about that. We're just going to delete the old fractionation methodology we were using. All right, and so now we're going to do, first, since we're going to use the UV in order to be able to turn the fractions on and off, I am going to auto 0. And then after I do an auto 0, I like to have a little bit of a delay before I start looking for the fraction. So I'm just going to enter in a delay block. Okay, so this is the delay block for the base's time. So it's going to wait for 0.05 minutes before anything else starts happening after the auto 0 for the UV, which would be what, like 3 seconds, I think. That's metric time for you, right? So I'm just going to close that block. All right, so now let's set up peak fractionation. So this is peak fractionation, but before we can do that, we need peak fractionation parameters. I'm just going to do a start level as 100 milliabsorbance units. I've actually run this before, so I know 100 works great. Okay, our mode is level right there, so, and then I'm going to do end level as well. And now that we have our parameters all set up, after the parameters, we can have the actual peak fractionation. And I'm going to do a 96 deep well plate and 2 mil fractions. Okay, and it'll run the separation for a total of 1.5 CVs, just like we planned. Okay, so that's it for the method itself. But you know, we need to change a few things. So first of all, I'm going to change the name. So I am going to save it as I'm going to use the method name for where I save it, and I still want it to be in training. Okay, so that's where the chromatograms are going to be saved. Now for the start protocol, I am going to add scouting to the start protocol, and I'm also going to do method information. Method information will tell me how long this run will take. Okay, so now this is scouting right here, and I can select any of these variables here. Okay. I actually don't have the length of separation as a variable, so let me put that in really fast. Okay, and then change. Okay, so now that I have a variable for the length of separation, I want to select that in the scouting as well. Length of separation. Okay, so now for the first run, right, I'm going to want to wash the sample buffer. And I'm going to do 2 runs, right? So what the first run would look like, and because you want the first run obviously would be different than the second run, because we can save some stuff, right? So for the second run, we don't want to wash the buffer or everything. The column position isn't going to change, right? And then the length of equilibration, well, on the second run, the column is already equilibrated, so we can do a 0 column equilibration. Or if we wanted to, we could just do a tiny little one just to sort of make things look clean. That's what I like to do. So I'm going to do 0.5. And then we want the length of separation to still be 1.25. Okay. And if you wanted to, you could put in your fraction information there for variables like start and stop fraction levels would be great, just in case like your sample ends up being like a little bit less or a little bit more concentrated than you think it is. All right, so that's how you would do scouting for that. Okay, I hope you found this helpful. Yeah, 2 different methods in one go for the Avant, which I think is valuable. I'm surprised I've never done a video like this before. Have a nice evening and good luck with your separations.